Welcome to Night Cosmos. Tonight we're diving into a story written not in ink, but in dust. Cosmic dust. Invisible, ancient, and everywhere is the quiet artist behind stars, planets, and even life itself. Before we begin, take a deep breath, let go of the day's worries, and remember to subscribe to Night Cosmos. Now, imagine the vastness of space. Dark, silent, and infinite. Floating there is more than emptiness. Between the stars, swirling in cold, thin clouds, are tiny particles that drift like ashes from a cosmic fire. This is stardust, and it's older than the Earth. In fact, much of what we are, our bones, our blood, our breath, comes from it. Over the next few minutes, let's explore how the universe used this seemingly insignificant dust to create everything we know. So, lie back, relax, and prepare to float through the gentle mystery of cosmic dust. Cosmic dust is made of incredibly tiny particles, far smaller than the width of a human hair. These particles come from dying stars born in their final, fiery breaths. When massive stars reach the end of their lives, they explode in supernovae, scattering their contents across the cosmos. Among those contents is dust, silicates, carbon, iron, ice, bits of the universe recycled into something new. These grains travel for millions or even billions of years, drifting silently across space. Sometimes they collect into clouds, forming beautiful nebulas. Sometimes they fall into newborn stars or gather to form planets. Dust might seem insignificant, but it's essential. Without it, stars wouldn't form, planets wouldn't exist, and life as we know it would be impossible. It's in the air of distant worlds, in the rings of Saturn, in the tail of a comet, and it's in us. We are, quite literally, made of stardust. Long before Earth was born, space was already filled with cosmic dust. These fine particles existed in the early universe created by the first generation of stars. When those ancient stars died, they released their elements into the void, seeding galaxies with raw material. That material became the building blocks of everything: stars, planets, moons, and even the very molecules that make up life. Dust served as scaffolding, tiny seeds around which gas could collapse to form stars. In nebulae, the densest clouds of dust and gas, stars are still being born today. These stellar nurseries shine in photographs from space telescopes, glowing with pinks and blues. Behind that beauty is the quiet work of dust, binding atoms together, shaping the cosmos. Without cosmic dust, the sky would be empty and cold. It gives the universe structure, substance, and soul, and it tells a story billions of years in the making. When scientists study cosmic dust, they're peering into the deep history of the universe. These grains are more than debris, they are time capsules. By analyzing their composition, we can learn what stars were made of, how they lived, and how they died. Some dust contains tiny diamonds or graphite, materials formed under immense heat and pressure in dying stars. Others carry traces of water, carbon compounds, or even complex organic molecules, the chemistry of life. These particles reach us in meteorites, in the tails of comets, or captured high in Earth's atmosphere. Each grain holds clues about the past, frozen in time and space. It's as if the universe left breadcrumbs for us to follow, whispering stories of ancient explosions, distant galaxies, and the shared origins of all matter. In the silence of space, dust remembers, and through it, we listen to the heartbeat of the cosmos. You might be surprised to know that cosmic dust is falling onto Earth every single day. Scientists estimate that about 5 to 60 tons of this space dust reach our planet daily. Most of it burns up in the atmosphere, creating tiny flashes of light or adding fine particles to our air and oceans. But some grains survive and settle gently on rooftops, mountaintops, and even in the deep sea. These microscopic travelers have journeyed across space for millions of years, only to land on your garden soil or kitchen window. It's humbling to think that something so ancient and cosmic is part of our everyday life. Researchers have even found cosmic dust in Antarctic ice, perfectly preserved for analysis. These findings help us understand where the dust came from and how long it's been traveling. The next time you see a shooting star, remember, you're watching cosmic dust burn bright one last time. In the vacuum of space, dust interacts with light in beautiful ways. When light from stars or galaxies passes through a dust cloud, it scatters and creates soft halos or glowing edges. This scattering can make starlight appear redder, a phenomenon known as interstellar reddening. Dust doesn't just reflect light, it also absorbs it, warming slightly and re-emitting energy as infrared radiation. That's how telescopes like Spitzer and James Webb can see dust not by visible light, but by the warmth it emits. These observations reveal hidden galaxies, star-forming regions, and the true shape of the universe. Some of the most breathtaking images of space owe their beauty to dust. It adds texture, depth, and mood to the cosmos, like fog in a forest. Though invisible to the naked eye, cosmic dust paints the universe with soft strokes of wonder, revealing the unseen drama behind every shining star. Despite its poetic presence, cosmic dust can also be a challenge. For astronomers, dust is both a gift and a veil. While it tells stories of formation and transformation, it also obscures our view of distant stars and galaxies. Telescopes must account for the effects of dust when interpreting data. That's why astronomers use multiple wavelengths, visible infrared, radio, to build a clearer picture of the universe. Even so, dust sometimes hides more than it reveals. It can blur the outlines of galaxies, block starlight, or distort cosmic background radiation. But rather than being a nuisance, dust interference is part of the mystery. It reminds us that the universe doesn't reveal all its secrets easily. Like a book half buried in sand, we must brush gently, patiently, uncovering meaning one layer at a time. Dust doesn't just conceal the cosmos, it dares us to look closer, to listen harder, and to imagine more deeply. As technology improves, our ability to study cosmic dust grows sharper. Missions like Stardust have actually captured dust particles from comets and returned them to Earth for analysis. These tiny samples help us understand the chemistry of the early solar system. Even more ambitious missions are on the horizon, aiming to collect interstellar dust and reveal its secrets. Scientists use special detectors on high-altitude balloons and satellites to gather particles too small to see. They analyze them in clean rooms, scanning their surfaces atom by atom. What they find are elements that predate the sun, matter that existed before Earth was even formed. Cosmic dust acts as a thread connecting us to the past. Every particle has a journey, and by following it, we trace the universe's evolution. In every speck lies a quiet story, echoing across time, whispering truths from the farthest reaches of the galaxy. In many ways, cosmic dust is the forgotten architect of the universe. It drifts through galaxies, unnoticed by most, yet without it, nothing of substance could exist. Every star, every planet, every moon begin with dust gathering, sticking, and building over time. In the early solar system, these tiny grains begin clumping together through static electricity and gentle collisions, forming pebbles, rocks, and eventually planetesimals. And over millions of years, these grew into planets. Earth itself began this way, as a slow swirl of dust and gas, gradually condensing into the world we know. Even the moon carries traces of this dust trapped in its ancient surface. It's strange to think that something so vast and powerful as a planet could begin with such humble origins. But that is the magic of the cosmos. From the tiniest things, the greatest wonders are born. And it all begins with a whisper of dust in the darkness. Cosmic dust doesn't just shape planets, it might shape life itself. Some scientists believe that the building blocks of life arrived on Earth via cosmic dust and meteorites. These particles can carry amino acids, the fundamental components of proteins. If true, it means life on Earth could have extraterrestrial origins seeded by the cosmos in a process called panspermia. In space, organic molecules form on the surfaces of dust grains, exposed to ultraviolet radiation. These molecules are then transported across galaxies, drifting for eons until they find a place to land, perhaps on a young, warm planet like early Earth. In this view, dust becomes more than matter. It becomes a messenger, a carrier of potential, linking life across the stars. The idea that every living thing might be connected through these tiny cosmic couriers is both humbling and inspiring. The universe, through dust, may have whispered the first sparks of life into being. One of the most mesmerizing places to witness cosmic dust in action is within a nebula. Those colorful clouds, captured in telescope images, are made largely of gas and dust. They are both graves and cradles of stars. When a star dies, it releases its contents into space, forming a supernova remnant or planetary nebula. That dust then joins other material to create the next generation of stars. It's a cosmic recycling process. Nothing is wasted. The Orion Nebula, one of the closest and most studied star-forming regions, is a vivid example of this process. Within its glowing clouds, new stars are being born right now, their heat shaping and lighting the dust around them. These scenes look serene, but inside, complex dynamics unfold as gravity, radiation, and matter interact. Dust is sculpted by stellar winds, pushed and pulled into new shapes. It's not just debris, it's the canvas and the paint of the universe. Our own solar system is still full of dust, though we often overlook it. The zodiacal light, for example, is a faint glow visible after sunset or before sunrise, caused by sunlight reflecting off interplanetary dust. This dust, left over from comets and asteroid collisions, forms a thin disk that stretches along the plane of the solar system. It's subtle but beautiful, a soft light that connects us to the greater cosmos. Even the rings of Saturn, while mostly ice, contain dust that contributes to their delicate shimmer. Dust also plays a role in shaping the behavior of spacecraft. When moving at high speeds, even a tiny grain of dust can damage instruments or alter a mission's course. That's why NASA engineers carefully consider dust environments during mission planning. Cosmic dust is more than background noise, it's a presence shaping everything from planetary systems to the way we explore the stars. It is everywhere, always. When you hold a handful of soil, you're touching a legacy that stretches back to the stars. Earth dust contains elements forged in ancient supernovae. Iron from dying giants, oxygen from stellar cores, carbon from red giants. These atoms, once part of distant suns, are now part of trees, oceans, animals, and people. The calcium in your bones and the hemoglobin in your blood were created in stars that died billions of years ago. That's not poetry, it's astrophysics. We are truly made of stardust, a phrase often used but deeply literal. Dust is the thread that links us to the cosmos, a reminder that we are not separate from the universe, but part of its ongoing story. When we gaze at the night sky, we're not just looking out, we're looking back, and in a way looking within. The stars and their dust live on, not just above us, but inside us, always. Cosmic dust doesn't just shape physical worlds, it inspires us. For centuries, humans have looked up at the stars and seen mystery, beauty, and possibility. Much of that wonder comes from how dust paints the cosmos. Photographers, astronomers, poets, all have been touched by the quiet magic of stardust. Ancient cultures wove myths about the Milky Way, imagining it as spilled milk or a celestial river, unaware that its soft glow came from countless stars and clouds of dust between them. Today, high-resolution images from space telescopes reveal intricate patterns in dust clouds, stirring emotions and curiosity. In a sense, dust is the brushstroke of the universe's art. It adds depth, color, and contrast, revealing the hidden structure of space. It reminds us that what seems empty is often full of unseen beauty. Through dust, the universe speaks in silence, inviting us to wonder, to imagine, and to dream beyond the stars. Our relationship with cosmic dust is only just beginning. Future missions will seek out new ways to collect and analyze interstellar dust, using advanced spacecraft and detection technologies. Scientists hope to uncover more about the origin of elements, the processes of star and planet formation, and even the potential for life elsewhere in the universe. The James Webb Space Telescope is already providing breathtaking images and data about dusty regions where stars are forming. In the coming decades, we may even send probes into dense dust clouds to study them up close. These efforts could reshape our understanding of the universe's life cycle. Cosmic dust may seem like a simple thing, but in its particles lie the answers to some of our deepest questions. Where did we come from? What are we made of? Are we alone? With each grain we study, we inch closer to the truth. Dust is not the end. It's the beginning. As we reach the end of our journey tonight, take a moment to reflect on the story written in dust. From the ashes of ancient stars to the breath you just took. Cosmic dust has shaped everything. It is the silent witness to creation, destruction, and rebirth. It moves without sound, creates without words, and carries the memory of galaxies within it. We often think of the universe as distant and cold, but through dust, it becomes personal. The same particles that float in the depths of space also rest in the palm of your hand. They connect you to stars, to the past, to all that has been and all that may come. At night, cosmos, we thank you for joining us on this quiet exploration. As you drift towards sleep, may you feel the gentle presence of the stars, and remember, you are part of this vast, beautiful universe. Good night, dreamer. Cosmic dust not only connects stars and planets, but also serves as a time capsule of the early universe. Some particles found in meteorites are older than our solar system itself. These pre-solar grains were born in ancient stars that exploded before the sun even existed. When scientists study these tiny relics under electron microscopes, they find isotopic fingerprints that tell stories billions of years old. It's like holding a fragment of a long-lost world in your hand. These grains offer direct clues about the environments in which they formed, environments we can never visit. Through them, we glimpse what the cosmos was like in its earliest stages. In a universe so vast, such connections are rare and precious. It's almost unbelievable something the size of a speck floating through space can survive billions of years, journeys through solar winds and impact with Earth, and still carry a whisper of its birthplace. Astronomers face challenges when observing distant objects, and dust often plays both hero and villain in their work. On one hand, it reveals beautiful structures and hidden galaxies when illuminated by starlight or observed in infrared. On the other hand, dust can obscure light from stars and distant galaxies, making them harder to study. That's why telescopes like the James Webb observe in infrared, allowing scientists to peer through dense clouds of dust that visible light can't penetrate. In this way, dust acts like a curtain, sometimes drawn, sometimes parted, shaping what we can and cannot see. Our understanding of the cosmos is filtered through it, but even this challenge becomes an opportunity. By studying how light changes as it passes through dust, we learn about its composition, size, and movement. Dust becomes not just an obstacle, but a tool. Another way the universe shares its secrets, subtly and silently, with those who learn to listen. Cosmic dust also plays a role in planetary weather and climate. On Earth, volcanic eruptions send ash and particles into the atmosphere, affecting temperature and cloud formation. But even beyond Earth, dust storms shape landscapes and weather. Mars, for example, is infamous for its planet-wide dust storms. These storms can last for months and block sunlight, drastically changing surface temperatures. On Saturn's moon, Titan, organic dust rains down from the atmosphere, forming vast dunes. Even the rings of Saturn, icy and majestic, contain dust that influences their structure and dynamics. Dust isn't just passive, it's active, shaping planetary systems in subtle but powerful ways. Understanding its behavior helps us model climate systems, plan space missions, and predict how worlds change over time. Whether it's swirling across deserts or drifting through space, dust leaves a mark. It is the smallest architect of landscapes, both on Earth and across the solar system. There's something poetic in the idea that dust, often seen as something to clean or avoid, holds the universe's deepest mysteries. It's in our homes, our air, our lungs, and yet it also dances in the void between stars. This dual existence reminds us of our connection to the cosmos. We are made of the same matter that fills the darkest corners of space. And just as dust gathers in beams of light through a window, so too does it glow in the vastness of space under the illumination of distant stars. That glow, faint yet persistent, tells us a story of creation, of cycles, of persistence. Dust teaches us that even the smallest things matter, that in the grand tapestry of existence, every particle has a purpose. It invites us to look closer, to appreciate the quiet forces shaping our lives and the universe alike. In dust, we find the divine hidden in the mundane. Cosmic dust might even offer insight into the universe's ultimate fate. As stars burn out and galaxies drift apart, dust will remain the leftover fragments of cosmic life. In a far future, where star formation ceases and black holes dominate, dust will still float, echoing the memory of a once brilliant universe. Some theories suggest that, in the end, the universe will grow cold and dark. a slow fading called heat death. But even in that scenario, dust may survive, a final witness to all that was. It might clump together again, pulled by the faintest gravity, sparking new possibilities even at the edge of time. We don't know for sure. But if dust has taught us anything, it's that from the quietest, most overlooked things, greatness can rise. And perhaps even in the end, the story of the cosmos will whisper forward through dust, waiting for a new beginning or simply resting in eternal stillness. Thank you for joining us tonight on this cosmic journey. As you close your eyes and drift into sleep, remember that the universe is not just out there, it's within you. The atoms that make up your body were forged in ancient stars, carried through time by dust, and brought together in the miracle of life. You are a part of this great story as much as any star or galaxy. At Night Cosmos, we believe in the power of wonder, and that even the quietest stories, like that of cosmic dust, can bring peace, awe, and connection. If you found this journey meaningful, consider subscribing to our channel and exploring more episodes under the stars. Let the music, the mystery, and the gentle truths of space guide your dreams. Rest well, traveler. The stars are always above you, and the dust of the universe is always with you. Good night, and may the cosmos watch over your sleep.